Okay, so here are our 3 zeros. Now whenever we have imaginary numbers always come in pairs. Conjugate pairs is what they're called. Complex roots always come in pairs. So I found this picture on the internet and I couldn't resist putting it in there. They always come in pairs. So if you have one imaginary number, you're going to have the other one. If I got out as a 0, 1 plus 3i, I automatically know I'm going to have its conjugate, 1 minus 3i. So whenever you have imaginary numbers, you're going to have 2 of them. Keep that in mind. Okay, let's look at another one. Maybe. Alright, let's find all the zeros of x to the 5th plus x to the 3rd plus 2x squared minus 12x plus 0. So our process is we put a 0 in for x, for y, and we try and solve out this equation right there. It's not going to factor very well though. So we're going to start by graphing it. We know we're looking for 5 zeros because it's of degree 5. So let's take a look at a graph. Put this in your graphing calculator and you see something like this. It has 2 zeros that we can see. Except this 0 is going through, so it's of multiplicity 2. So I know I have a 0 at -2. There's one of my zeros. Here's a 0 at 1. But look at that 0, it's just touching the axis and it's coming back up. So that's of multiplicity 2. So I'm going to count it twice. It counts as 2 zeros. So I've got 3 of my zeros already. I need the rest of my zeros. So we're going to do some synthetic division here. We're going to try to take this 5th degree polynomial and depress it clear down to a quadratic. So if you remember, we've done this before. Start with one of your zeros. Let's start with -2. I'm going to put -2 in my synthetic division box, and I'm going to divide. So write your coefficients down. I have 1. X to the 4th is 0. X to the 3rd is 1. X squared is 2. X is -12. And then I have an 8 on the end. And I should be getting a remainder of 0 because this is a 0. So I drop down the 1. 1 times -2 is -2. Add down, I get -2. Multiply, -2 times -2 is 4. Add down, we get 5. Multiply, 5 times -2 is -10. Add down, we get -8. Multiply, -8 times -2 is 16. Add down, we get 4. Multiply, 4 times -2 is -8. Add down, we get 0. Okay, so it was a 5th degree, now this is a 4th degree. I got my remainder of 0, but it's a 4th degree. We're trying to get it down to a 2nd degree, down to a quadratic. So I'm going to keep dividing. I already divided by -2, let's divide by 1. So put 1 in the box, drop down your 1, and start your synthetic division. 1 times 1 is 1, add down we get -1. -1 times 1 is -1, add down we get 4. 4 times 1 is 4, add down we get -4. -4 times 1 is -4, add down we get 0. Okay, so we're depressing this polynomial. It was a 5th, here it was a 4th, now it's a 3rd. We're almost done. We need to divide one more time to get it down to a quadratic. So I'm going to divide by 1 again. Drop down the 1. 1 times 1 is 1. Add down, we get 0. 0 times 1 is 0. Add down, we get 4. 4 times 1 is 4. Add down, we get 0. And we're left with a quadratic. That's our goal. We're trying to get down to a quadratic. So now we have x squared plus 4. And you set that equal to 0 and solve it out once you get your quadratic. Now sometimes you're going to have to put it in quadratic formula. This one you don't have to put in quadratic formula. You can just get x by itself. So I'm going to subtract 4 from both sides. And I get x squared equals -4. And then take the square root. And we get x equals plus or minus square root of -4 is 2i. So our zeros are -2, 1, 1, positive 2i, and -2i. There's our 5 zeros. So on your assignment today, you're going to be given different polynomials. Whatever degree they start with, you're trying to get them down to a quadratic. Get them down to a 2nd degree. So you're going to put it in your calculator and then start dividing until you get it down to a quadratic. Well, let's try one more. Okay, let's try this one. 2x to the third minus 5x squared plus 18x minus 45. We start by graphing it. So put this in your graphing calculator. There we go. And you're looking for a 0. We know we should have 3 zeros because it's a third degree polynomial. So we're looking for 3 zeros, but when you put that in your graphing calculator, we only see 1 at 2.5. So I need 2 more zeros. The other ones must be imaginary zeros because I don't see them show up on my graph. So I'm going to take my polynomial and I'm going to start dividing. Inside my synthetic division, that's where I use my real 0. 2.5 is my starting point. I put 2.5 inside my box and I start dividing. My coefficients are 2, -5, 18, and -45. So I divide, I should get a remainder of 0. Drop down the 2. 2 times 2.5 is 5. Add down, I get 0. 0 times 2.5 is 0. Add down, I get 18. 18 times 2.5 is 45. Add down, I get my remainder of 0. And now I've gotten it down to a quadratic. That one only took 1 time to get down to a quadratic because it started as a third degree. Now it's a second degree. So now I have 2x squared plus 18. And I'm going to set that equal to 0 to find my imaginary zeros. So from here, sometimes you'll have to put it in quadratic formula. This one you don't have to. Just subtract 18 from both sides. We get 2x squared equals -18. Divide off your 2. X squared is equal to -9. And then take the square root. And we're going to get our other 2 zeros as plus or minus 3i. So our zeros are 2.5, 3i, and -3i. And we're done.